So let's begin at the start with step 1, which is data import. If we refer back to the flowchart that we were looking at a moment ago, we're going to start here on the left-hand side of the workflow, beginning with the various different input data sets, which you can see highlighted in blue. These cover a variety of different open source environmental data sets, including water quality data, river habitat survey data, environmental data about ecology sampling locations, the ecology data itself, as well as river flow information, which we can obtain from various different sources. You can see highlighted with the red box there the various different functions from the HE Toolkit that we can use to access that information. You will also see highlighted on the slide there a dark blue box, which we've called a metadata file. And the metadata file is the starting point because it provides the basis for listing out all the different sites or locations that we want to obtain data for. So, beginning with the metadata file, the metadata file is simply a lookup table of site IDs that tell the HE Toolkit how to link together various disparate data sets. You can see an example on the slide here. We have a table with 4 columns. The first one lists out the site IDs for our ecology data, in this case macro invertebrate sampling IDs. Column B lists out the IDs for corresponding flow gauging stations. Column C tells the HE Toolkit where to get that flow data from, and column D lists out IDs for river habitat surveys. Again, these are paired up with each of our invertebrate sampling locations. All of these pairings need to be identified manually. That's not something that the HE Toolkit can do automatically for us. So to create this metadata file requires a little bit of groundwork, either looking at maps or some GIS analysis to work out for each ecological sampling location where is the nearest or the most appropriately located gauging station, where is the nearest or most appropriately located RHS survey, and so on. All that information can be gathered together in a simple Excel table and then imported manually into R, and that provides the starting point for then extracting these data sets from different online databases. The only thing I would just draw your attention to at this stage is that the use of the standardized column names. So we've got biology site ID, flow site ID, flow input, RHS survey ID, and so on. You don't have to use these column names, but these are the column names that some of the data import and later functions are default to. So if you set up your metadata file with these column names, it streamlines the process and it makes it easier to daisy chain various different functions together. These different data import functions available within the HE Toolkit all provide API access to various open source databases. So an API is an application programming interface. You can think of it as a data pipeline that gives us direct access to a remote database and allows us to suck that data directly into the R environment. Each function essentially requires as an input a list of site IDs, which we take from the metadata file, plus a start and an end date, which defines the temporal range over which we want to import data. The functions, as they bring the data into the R environment, and they also provide the option to save down a copy of the imported data and save that locally on your machine as an RDS file. So an RDS file is just a specific file format for storing an individual R object. This really just provides an opportunity to create an audit trail. It gives you a permanent copy of the data that you've imported. And also, if you're importing large volumes of data, that can be a slightly slow process. So by doing that once, storing it locally and then reading it back into R, that provides a slightly more efficient way of working through your script each time. We're going to start off by looking at the various functions for importing flow data. The HE Toolkit actually has 4 separate functions, all of which allow us to import daily mean flow data, but from different sources. Your usual starting point would typically be the import HDE function, because this provides access to the Environment Agency's Hydrology Data Explorer tool. You can see the link to it on the slide there. It's essentially a website with a database sitting behind it, which contains it's the primary source really of flow data from gauging stations across England. You can use the website to identify where those gauging stations are and work out which one is best paired up with each of your ecology sampling locations. If you can't find the data that you're looking for on the Hydrology Data Explorer, then another good source of flow information is from the National River Flow Archive, which is a database of information from around 1,500 gauging stations across the whole of the UK, not just England, that's maintained by the Centre for Ecology and Hydrology. And to access the data from that source, we have a sister function called import NRFA. The third function in the toolkit is called import flow files. So if the gauging stations that you're interested in are not available on the Hydrology Data Explorer or the National River Flow Archive, or if perhaps you're using modelled flow data, then import flow files, it allows you to batch import data from one or more local data files you already have stored on your machine. It's a fairly flexible function because it allows us to read in flow data from a variety of different file formats, including CSV, text files, .or files, as well as old and new versions of Excel workbooks. Finally, we have the import flow function, and this is a high-level wrapper function which calls the 3 previous functions and essentially allows us to import data from a mix of sources quickly and efficiently without having to use each of those other functions separately and then manually stitch the data together. So let's have a look at each of those functions in turn, starting off with import HDE and import NRFA. These 2 functions work in a very, very similar way, and they both produce a table of flow data, that's daily flow data, in QMEX for the specified sites and dates. On the left, you can see an example of the code that we would use to run those functions in R. Starting at the top, we've got the import HDE function. To run that, we need to give it a list of site IDs for the particular gauging stations that we want data for. And then we can optionally also specify start and end dates, which just mean the data is filtered or truncated to remove anything before the start date and anything after the end date. And what that produces is the data table you can see on the right, which has 4 columns. The first column just lists out the ID for each gauging station. We then have a date column, a flow column, and then also a quality column, which provides information about the quality of the data. So all of those mean daily flow records will be subject to a QA check, and the quality column will flag data that's been checked that is suspect, or as you can see in this example, records or observations that are missing as well. The import NRFA function works in an almost identical fashion and will produce a very, very similar table. The only difference being that the National River Flow Archive doesn't return any information about the quality or reliability of the flow data. So that 4th column will always be blank or NA. So these first 2 functions allow us to import data from remote online databases. The import flow files function, by contrast, imports data from local files which we have obtained or downloaded to our machine already. I've got an example here on the right hand side of the slide of a data set in an Excel format. The key thing to note here is that we have a series of column headers at the top, which give information about the name, the ID of the gauging station, what river it's on, and so on. The actual gauged flow data doesn't start until row 22, where we have a sequence of dates and measured flows. The way we set up this function is to, first of all, give it a list of site IDs so it knows which gauging stations or data sets we're interested in. The key thing here is that those site IDs must match up with the names of the local files. So, for example, the first site is 0130th. So the function will look in the folder that we tell it to identify any files with that file name. It looks in the folder which is indicated by the directory argument. So here we're asking it to look in a folder called data, and in there's a subfolder called whiskey. So essentially it's looking for files which we've exported from the EA's whiskey database. The next argument is skip num. So here we're telling it to skip the first 21 rows of the data set and start importing data from row 22. Another thing we need to tell it is the column order. So this is the position of the columns that contain the date, flow and quality data. So here the date is in column 1, the flow values are in column 2, and the quality or reliability information is in column 3. So the column order is 1, 2, 3. If your data doesn't have any quality information, then the third element of that argument can be NA. So for example, 1, 2, NA. Dates are particularly tricky because they can be presented in a variety of formats. So the date format argument allows us to tell the function exactly how the different elements of the date are arranged. So here we've got dates which are day, month, year, hour, minute, second. The documentation associated with this function explains how to specify alternative date formats. This function allows us to batch import data from multiple files. The only caveat is that all of those files, they can be different formats. So you could have a mix of CSV and Excel files, for example, but they must all have the same underlying structure. That is, the same number of header rows, the position of the key columns should be in the same order, and the date format should also be identical across all of those files. What this function produces is a table of data in long format, very similar to that which we saw being returned by those other functions. Again, flow site ID, date, flow, and quality information. Fourth function for importing flow data is import flow. And as I mentioned before, this is a high-level wrapper function. So if we have information or data that we want to import from different sources, we can do all of that in one hit using this one function. Again, we give it a list of site IDs, a start and end date. If we're importing local files as part of the mix, then we need to specify the working directory, the skip num, and the col order arguments as well. The key thing we need to add into the function here is a list of inputs. So drawing on the metadata file, you can see that the small table at the bottom of the slide here lists 5 different site IDs or locations that we want flow data from. The first 2, we want to get that information from the Hydro-Ecology Data Explorer. The third and fourth locations, we have local files, so we specify flow files as the source of that information. And the fifth location, we're going to get that data from the National River Flow Archive. So that really just illustrates how we can import data from a mix of different sources. And the output table that it produces is shown on the right-hand side here. It's identical to all the others, except we now have an additional column on the left-hand side of the table, which confirms the input or the source of the flow data for each location. So the HE Toolkit therefore allows us to import flow data from both online and offline sources. But there are many other types of environmental monitoring data that we might be interested in as well. And this slide summarises 4 other functions that we have for accessing different types of data. The first of those is the import INV function, which allows us to access macroinvertebrate sample data from the Environment Agency's Ecology and Fish Data Explorer. Again, there's a web link there. If you're not familiar with the Ecology Data Explorer, you can have a browse on the website, and it provides a ready way of identifying where invertebrate sampling locations are, so you can extract the relevant site IDs. The import env function imports the environmental base data that's associated with those macroinvertebrate sampling sites. So that tells us information about the physical characteristics of those sampling locations. Thirdly, we have the import RHS function, which downloads river habitat survey data, which is hosted on DEFRA's open data platform. Again, we can do this for a user-defined set of RHS survey IDs. And fourthly and finally, we have the import WQ function, which allows us to access open source water quality data from the Environment Agency's Water Quality Archive. Again, this is a very substantial database of spot sampling data that goes all the way back to the year 2000. Since we wrote these slides, that import WQ function has now just been released in March 2023, so that is now available within the HE toolkit. So let's look at each of those four functions in turn to see how we can configure those functions and what data it returns for us. Starting with import INV, this allows us to import macroinvertebrate sample data. The code on the left-hand side of the slide shows us how we can, first of all, specify the source of that flow data. If we're downloading data from Ecology Data Explorer, we can download it in at least two different formats. A Parquet file, which is a super compressed file format, which means if we're bulk downloading large volumes of data, that's a fairly sort of quick and efficient way of doing it. It also means that the data columns come pre-formatted. Or if you prefer working in CSV, you can also import the same data in a CSV format. You can also, if you wish, give the import data that you've already downloaded to your local machine, in which case you specify the source as being a previously saved CSV, Parquet or RDS file. Next, we list out the site IDs. So this essentially filters the data down just to the sites of interest. And then again, we can specify start and end dates if we want to filter the data to certain years, for example. The function returns a data table with one row for each invertebrate sample. And it's quite a wide table. We have a total of 58 different variables. So as well as the site ID, the sample ID and the sample date, we have a very long list of different macroinvertebrate indices which have been calculated for each sample. And these include all of the commonly used invertebrate metrics such as WHPT, N-taxa, life and PSI, as well as many others. Alongside the import INV function, we have the import env function. And this allows us to extract from the Ecology Data Explorer the environmental base data, the physical characteristics for each of those invertebrate sampling locations. This is one of the simplest functions to use because all we need to specify is a list of invertebrate sampling site IDs. It returns a table of a total of 34 variables, so one row here for each sampling location. And this includes information about the Environment Agency area, the name of the catchment that the site is located in, coordinate information, as well as all the variables that we need for calculating expected scores using the RICT tool. So these include variables such as altitude, slope, width and depth, and substrate information, as well as alkalinity, conductivity, and hardness. The next function is the import RHS function. This allows us to download from DEFRA's open data platform information associated with river habitat surveys. So river habitat survey is a standardized method for recording information about the habitat conditions over a 500-meter length of river. More than one survey can potentially be undertaken at a given site. So rather than specifying sites, we specify individual survey IDs. So here the challenge is to find the survey ID which is closest in time and space to our invertebrate or other ecological data. To run the function, you can see the code on the left here. We just simply specify a sequence of RHS survey IDs, and that returns a data set, which you can see on the right there, which gives the survey ID, the survey location, the site ID, and then again, it's quite a wide table with a total of 77 columns. There's a lot of information here about channel dimensions, so width and depth. We have a sequence of habitat modification scores which quantify the extent and severity of different types of modification, including bed and bank reinforcement, resectioning, weirs, bridges, poaching, and so on. You'll also see it returns a set of HQA scores, habitat quality assessment scores, which give us information about the occurrence and diversity of habitat features both in channel and along the riparian margins and the floodplain. So that gives us information about the diversity of habitats within the river and also the conservation value of those. Finally, the import water quality function allows us to access spot sampling data that's been collected by the Environment Agency across England. We specify a list of sampling locations, so these could be WIMS site IDs, for example. We need to tell the function which determinants we are interested in. There's clearly a very wide range of determinants or water quality parameters that can be sampled. So here, setting debts equals all will give you absolutely everything that's been sampled or analysed at that sampling location. Or you can set it to default, which gives a more restricted set of the more commonly or widely used water quality parameters. You can see those listed in the table on the right-hand side here. So we have pH, various nutrient parameters such as total oxidized nitrogen, nitrate, nitrite, orthophosphate. We also have suspended solids, water temperature, conductivity. So essentially a lot of the common nutrients and physical chemical parameters, including all of the commonly used WFD water quality parameters as well. You can also, if you're interested in very specific parameters, list those individual determinant codes in the depths argument as well. The table on the right just gives you an example of what you get back from this function. So again, the data is in long format. So if we're importing data for multiple sites, that will all be stacked up on top of each other. We have the water quality site ID. We have the date that the water quality sample was taken. We have the name and ID of the determinant. The result column contains the actual numerical concentration values. And then the units, and then the qualifier at the end is flags any measurements which are below the limit of detection or occasionally greater than values as well. So together, all of those import functions allow us to read in data from a variety of different online and offline sources. But we do recognise that those functions, whilst they're fantastic and very flexible, they won't necessarily always meet your needs. And there will be occasions when you need to bring in supplementary ecology, water quality or other environmental data from other sources. And that needs to be manually imported into R. So obviously you can do that. The key, I think, is to try and either structure that data or manipulate it to match the structure of the data that you've imported from these other standardized databases. And if you can achieve that, then it's a relatively straightforward process to combine the open source data with that supplementary data using, for example, the rbind or bind rows functions within R. So that's really been a sort of an overview of the various different data import functions which are available in the HE Toolkit. If you'd like to hands-on with using those functions, then please feel free to delve into the practical exercises which accompany this training workshop. Practical exercise 1 provides some example scripts for accessing and running all of the different functions that we've just covered in this module.